Hello, you're with Bahati Abdul Karim, and I'm going to take you through A-level applied mathematics, specifically projectiles. It's suitable for students who are doing mathematics at A-level, Senior 5 and Senior 6. Let's look at our course outline of what we're going to deal with. So we're going to look at the definition of a projectile, and then horizontal projection, projection at an angle, release at an angle from a given height, and then lastly examination style questions. Specifically for this lesson, we are going to look at only these two things: definition of a projectile and horizontal projection. Let's first understand what a projectile is before we dive deep into calculations. First of all, a projectile is an object that is launched into the air and is then acted on only by gravity. So whenever you launch anything, any object into the air, and the object is acted on by gravity, we call it a projectile. When modeling projectiles, objects are modeled as particles, and factors such as air resistance and spin are ignored. So in this case, we are not going to ask you to calculate air resistance or to put into consideration air resistance or put into consideration spin. No, we just ignore them. Then the path that a projectile takes is two-dimensional. That means it is in x and y directions, and it is known as its trajectory. So the path taken by a projectile is called a trajectory, and it is parabolic in nature. So the shape of a projectile's trajectory is parabolic. So you should always remember that. If the parabolic thing doesn't make sense right now, don't worry about it. You're going to understand by the end of the lesson. So let's look at some factors that determine the motion of a projectile. The first factor is the initial velocity. Whenever you're launching something into the air, you must give it some initial velocity. With zero initial velocity, the object won't move. So you have to at least give it some initial velocity so that it can move it to some other point. Then the next factor that affects the motion of a particle is the angle of release. So whenever you project an object into the air, you release it at some angle, and that angle will always affect its motion. And then the next thing is the point of release and gravity. So whenever you release an object, you may release it from the level ground or from some height above the level ground. So that will affect the motion of the particle. And also the force of gravity will have to act on that particle as the particle is moving. So gravity will also be a factor that affects the motion of a projectile. We can look at some examples of projectiles, and the first one is an arrow fired at an archery target. So whenever you fire an arrow, then the arrow becomes a projectile. A golf ball hit off the tee. Some people play golf, and amongst you also there might be some who play golf, but you should know that whenever you launch a golf ball, then it becomes a projectile. So a stone kicked off the top of a cliff also will be a projectile. A tennis ball served horizontally is also a projectile. A cricketer hitting a ball, the ball becomes a projectile. A child throwing a ball at a wall, the ball will also be a projectile. A gun firing a shell, the bullet in that case will become a projectile. And then a cricket bowler releasing a ball, then it will also be a projectile. So after understanding what projectiles are, we can look at the next thing on our course outline, which is horizontal projection. So we're going to understand what horizontal projection is, and then we do some calculations on horizontal projections for this video. So let's first look at what horizontal projection is. When you look at this stone, it was projected from this point here, and it moved all the way up to this point here. But when you look at the way it was projected in a horizontal direction, and then it moved downwards until it reached this point. So this kind of projection, we call it horizontal projection. In this kind of motion, the object is always given some horizontal velocity initially. So this velocity will always remain constant for horizontal motion because there is no acceleration in the horizontal motion. For vertical motion, initially the particle is not given velocity here. As you can see, the particle was released horizontally. So u in the y will always be 0 for horizontal projection. But the v in the y will not be a 0, it will be some value that we don't know. So always in projectiles, you will have to remember that you consider the motion of the particle in two directions, the x and the y direction. This height you see here is the vertical distance, or the distance traveled in the y, and the distance traveled in the x will be this distance up to where the stone hit the ground. So here you'll always have to consider the motion of the particle in two directions if you want to pass projectiles. So when a particle is projected horizontally, we model it as having 0 acceleration. There is no acceleration in the horizontal, and hence in the horizontal direction the velocity will always be constant. In this situation, the particle has 0 initial velocity and a constant acceleration g downwards in the vertical direction. So you will have to always remember that, as I have told you, horizontal direction there is no acceleration, but in the vertical direction the acceleration is constant and it is g, and for horizontal motion it will be downwards. Also the direction matters, because you know when a particle is going down it doesn't oppose gravity, but when the particle is going up it opposes gravity. So let's look at the first question of horizontal projection. We have a particle projected horizontally with a velocity of 20 meters per second from a height of 19.6 meters, and they want us to find the time the particle takes to reach the ground. Here the time is what they are after. So we are going to find this time, and then the horizontal distance traveled. Here I can call it as x. In projectiles, we are going to be using the 3 equations of motion, but remember that you're going to be considering these motions separately. Motion in the x direction must be considered separately, and the motion in the y direction must be considered separately. Don't worry, we are going to look at all of these. So let's look at the way the particle was projected. So this particle was projected from this point, which is 19.6 meters above the level ground, and then it was given initial horizontal velocity, which is u in the x direction, and this velocity is 20 meters. And then we have said that for horizontal projection, the u in the y is always equal to 0. U in the y is always equal to 0, and our u in the x here is 20 meters per second. As I have told you, you will have to consider these motions both in x and y separately. So this particle will travel some distance in the y, which is this distance, and it will reach with some velocity here. So it will reach with some velocity here, which we can call v. But this v has two components. It has v in the x direction and it has v in the y direction. So this v in the x, we said it is the same as the initial velocity. It will be 20 meters per second because there is no acceleration, so the velocity remains constant. But the v in the y, we do not know it. So as you can see, I have almost summarized everything. So here, this is the distance traveled in the x direction, and this one is the distance traveled in the y. So this is almost all the information that we have about our question. And after looking at this information here, actually you can be organized and summarize the information for x aside and the information for y aside, so that you can see which one has more information and you can use it. I think I'm going to go ahead and do that, and I'm going to first rub off what is here. So from this question, I'm going to summarize this information in an orderly way. So let's see how I'm going to summarize this information. Let's start with x. As I told you, you're going to always consider x and y directions separately for projectile motion. So let me summarize this information, and as you summarize, you have to bear it in mind that we are summarizing depending on the parameters in the three equations of motion, that is acceleration, displacement, time, initial velocity, and final velocity. So let me start with x. For x, we shall have displacement s in the x direction, which we do not know. We shall have initial velocity u in the x direction, which I can call 20 meters per second because that's what they gave us. Then the final velocity in the x direction will still be 20 meters per second, since there is no acceleration in the x direction. This will happen for all projectile motion. And then let's have time t, which we can call t because we don't know it, and then acceleration in the x direction will always be 0. That will also happen for all projections. And then I think we have all the parameters. For y, let me summarize it here first. So for y, we shall have s in the y equaling to, they gave us 19.6, the displacement in the y. Then for initial velocity in the y, as I told you, for horizontal projection it will always be 0 meters per second. And then if I want to write final velocity in the y, this one we don't know it, but it can be found. Then time will be time, and acceleration will always equal to 9.8 meters per second squared. So when you look at this information, this one here is for x, and this one here is for y. So always summarize your information given in the questions for projectile motion, and then from there you can know which side you're going to take first to determine what you do not have. So for example, in this case, when I look at the x values, I have ux, I have vx, and I have ax. These values, they cannot give you time and they cannot give you displacement. But when you look at the values for y, you have displacement, you have uy, you have acceleration. These three values substituted in the second equation of motion can give you time. And that time, when you bring it into y, into x, you can get the displacement in the x direction, which is in the question. So here we can use the second equation of motion, and in the first place we are considering vertical motion. So I will say S is equal to ut plus a half a t squared. That is the second equation of motion, and we are considering motion downwards. So what is our S? Our S is 19.6 meters, and our U is 0, and our T is T because we do not know it. Our acceleration is 9.8, and that is all we need to find the time T. So in this case, since we know our S, that it is 19, I put 19 here. I say 19.6 will equal to U is 0, so I say this gives me a 0, then plus a half times 9.8 t squared. So here you realize that you already have your time, because if I simplify this, it will be 19.6 equaling to 4.9 t squared. Divide by 4.9 by 4.9, and you will have your t equaling to 4. Take the square root, this is t squared. Take the square root both sides, you will have t equaling to plus or minus 2. And since time can never be a negative, we shall have to say t is equaling to 2 seconds. We disregard the negative. So that's how we have managed to calculate the time taken by the particle to reach the ground. Then the next thing we shall need is the horizontal displacement. So after getting this time, we can come and use these parameters of x, and we can now get the displacement. So let me now erase this work so that we can do. Let me first remove this. So this is exactly how our work for calculating time taken should be. And then now let me erase this one, and we calculate the displacement in the x direction. We are going to still use these parameters we put here. So let me rub this. Don't worry. As you can see, I'm rubbing slowly. So we know that our time is t seconds. So after calculating time, we can now use that time to calculate the displacement in the x. So from here, let me get a pencil. So from here, you realize that if I still substitute in the second equation of motion, which is S is equal to ut plus a half a t squared, you realize that our S is unknown, our U is known, our T is also known, it is here, and our acceleration is known, so we can calculate the displacement. So we know that if we substitute in here, we shall get our Sx, which will equal to U, which is 20, times time, which is 2, and then plus a half times 0, times 2 squared. This will give us Sx equaling to 40 meters. This is the horizontal displacement as it was asked in the question. Let me hope it is easy. Because it is. They asked for how long, that is the time, and then they asked for the horizontal distance traveled, that is from here up to here. So I think we have finished our question 1. Let's go to question 2. Question 2 says a particle is projected horizontally with a velocity of 10 meters per second, travels 40 meters horizontally before reaching the ground. Find the height from which the particle is projected. So in this case, they want us to find this distance here. And that's all. So in here, you will have to summarize your data again the same way as we did. So we know that our initial velocity in the horizontal direction is 10 and our initial velocity in the vertical direction is 0. Our horizontal displacement is 40, so that's all we have. So let's go and answer this one. So let's summarize this equation for x and y. So we know Sx is equal to 40 meters. That is the distance traveled in x from here up to there. Then u in the x direction is 10 meters per second. Then we know that v in the x direction will be the same as 10 meters per second. And acceleration will be 0 for x direction. And then lastly, t is unknown also. So when you look at this information for x, you realize that it is enough for you to calculate time t. Then you can also summarize the information for y, which is, let's say sy is unknown and this is what they want. We know that u in the y for horizontal projection will always be 0. Then v in the y will have a value. Then acceleration will always equal to 9.8 meters per second squared. And then lastly, the time will be the same as the time in the x direction. So you realize that this information for y is lacking. So we can use the information for x to get time t, and we now bring the time t in this equation in this y direction. Then we find the displacement from where the particle was, at the distance from where the particle was released, and we are using the equations of motion. S is equaling to ut plus a half a t squared. I will have s as 40 and I will have my u as 10. Time I do not have it, plus a half, and here we are considering horizontal direction, and acceleration will be 0, then times t squared. So here I will have my 40 equaling to 10t. I divide by 10, I divide by 10. So my time will be 4 seconds. As simple as that. So after now getting your time t, you can go ahead and calculate this distance from where the particle was released, and still using the same equations of motion. So let me erase that work and then we calculate the vertical displacement. So we are going to still use the 3 equations of motion. So we pick the equation that has what we want, and in this case, if I use the second equation of motion, because I have time t as 4, I have my acceleration as 9, and I'm looking for displacement and I have u as 0, this can give me the displacement using s is equal to ut plus a half a t squared, and we are considering vertical motion downwards. So we shall have displacement in y as our sy equal to u, which is 0, times the time, which is 4. We calculated 4 plus a half times 9.8 times 4 squared, as our time is 4. So here we shall have sy equal to 0 plus 9.8 divided by 2, you'll get 4.9, then times 16. And finally, you will have your vertical displacement as 78.4 meters. Full stop. As simple as that. I think you can see how simple projectiles are. This is horizontal projection. No one is supposed to be failing such kind of, no one is supposed to be failing this simple work. So I think you can see that these questions are very, very, very easy. Let's now look at our question 3. Question 3 says a particle is projected horizontally from a height of 44.1 meters. It travels 36 meters horizontally before hitting the ground. Find the velocity with which the particle is projected. So you realize that they are just denying you some information and giving you some information. And in all this, we are just using the 3 equations of motion. Just summarize your information, pick the equation that fits the information you have, then use it. So in here, they have denied us the u. So we are going to look for the initial velocity, and that is in the x, because we said in y it is always 0. And that's all. So we do the same, we summarize our information. We have the vertical height as 44.1 and the horizontal height as 36 meters. So let's go summarize this information and then we answer the question. So we know if I start with x, our displacement in the x direction, sx was, let's go back and check, sx was 9, actually sx was 36 meters and sy was 44.1. So let's summarize our information. Our sx was, let's go back and check, 36 meters. Our initial velocity in the x, we do not know it. Our final velocity in the x will be the same, but we don't know it. Our acceleration in the x will be 0. And lastly, the time taken, we do not know it. We can still call it time t. For y, the s in the y will be, I think it was 44. Yes, 44.1. And then u in the y, we know it will always be 0. V in the y has a value, but we don't know it. Acceleration in the y will always be 9.8 meters per second squared if the particle is going down, and then time will be the same as time for x. So this time we can call it t. So we call our time t. So from here, I think when you look at this information, you realize that the y direction has more information. So we can use the second equation of motion, which is S is equal to ut plus a half at squared. And in this case, our S is, we are considering now the vertical motion in the y direction. We have 44.1 equaling to u. Our u is 0. It will always be 0 in the y, times t, you can put it there, plus a half times acceleration, which is 9.8, then times t squared. So here we shall have 44.1 equal to 4.9 t squared. That is 9.8 divided by 2. And then when we divide by 4.9 by 4.9, we shall have t squared equal to 9. And then when we take the root both sides, we shall have our t equal to plus or minus 3. And finally we disregard the negative and our t will be 3 seconds. I think you can see how simple life is when you're dealing with projectiles. As long as you know how to manipulate the 3 equations of motion, you're good to go. So now time is done, and what they wanted was, they wanted us to find the velocity with which the particle is projected, that is u in the x direction. So we come erase this information. Since we have our time t already, we now erase this and we work out the u in the x. So we can erase this and leave our time. So you can see how things are nice when you're dealing with projectiles. So do not worry about this. So let's now calculate the initial velocity in the x. So we are still going to use one of the 3 equations of motion, and we are using the second one, which is S is equal to ut plus a half at squared. So you realize that our Sx is 36 and our u in the x is what we do not have. You can use it as ux, or you can still let it be maybe y, and then our time is 3, then plus a half. We know we do not have acceleration in the x, so it will be 0 times t squared. So finally we shall have 36 equaling to 3 ux. You divide by 3 by 3, and u in the x will end up being 12 meters per second. So you can now conclude you have your velocity, your initial velocity in the x direction. I think you can see how simple life is when you're doing calculations related to horizontal projection. Let's now look at our 4th question, which is our last question in this video, and we shall look at the projection at an angle in the next video. So this question says a particle is projected horizontally with a velocity of 15 meters per second from a height of 19.6 meters. Find the velocity with which the particle hits the ground and the angle it makes with the horizontal at this time. So this is our particle, and that's how it moved. So the angle we are interested in is this angle here. To find that angle, you just need 2 things. You just need the horizontal velocity Vx, that is the velocity in that direction as the particle is going in that direction, and you need the vertical velocity Vy. And in that case, you can find this angle, because this angle here will be alternating with that one. So you just need the 2 components, Vx and Vy, and you use the tan theta. When you use the tan theta, it will be opposite out of, and adjacent and you can get the angle theta. So here, since we know that the horizontal component of velocity does not change, we know that 15 meters per second will still be our final velocity in the x. Then what we have to look for is the Vy. After getting Vy, we're good to go. So let's now go and look for V in the y. So we summarize our information as usual. Our s in the x is equal to, they give us s in the x. There is no s in the x, so our s in the x is not given. Then our u in the x will be, they gave us 15, so we have 15 meters per second. Our v in the x will be the same as 15 meters per second. Then our t will be t, we do not have it. Our acceleration will always be 0 meters per second squared. For y, our s in the y is given as 19.6. It's here, 19.6. And our u in the y for horizontal projection will always be 0, I will say meters per second. And our v in the y will always have a value that we can calculate. Our t will be the same as for x, and our acceleration will always be 9.8 meters per second squared if the particle is going down. So from here, I think you realize that we are going to use information for y because it is more. So in here we can use now the third equation of motion, which is v squared is equal to u squared plus 2as. And you realize that when we do that, we are now looking for the we are looking for the final velocity v in the y direction, because we said for us to find the angle we need the final velocity and the final velocity in the y and in the x. So in here our v squared will equal to, we are considering vertical motion, will be u, which is 0 squared plus 2 times acceleration, which is 9.8 times the displacement, which is 19.6. So here we shall have v squared equaling to 2 times 9.8, you will get 19.6 times 19.6. So when you take the root both sides, you realize that your v will be 19.6 meters per second. That is your final velocity in the y direction. So after getting this one, you're done, because you have to just make two components for velocity in the x and y, then get the resultant velocity and get the angle if you want, because that's what they want. So from here, after calculating velocity, we know our velocity is 19.6 meters per second. Let me erase this part so that we can use it to calculate. We know our velocity is 19.6, and we can now use it. Let me show you. 19.6, let's keep it in mind. Let's write it now here. Our velocity is in the y is 19. Grab here so that we put it there. Don't forget it. It's 19.6 meters per second. So let me now show you how we are going to calculate the resultant velocity and the angle. So first of all, we have the horizontal component of velocity as 15, and we have the vertical component of velocity as 19.6. So with these two components, we just need the resultant and we need the angle, which is theta, and that theta can be the same as that theta. So that is the angle we need. So in here you see that these are triangles. You can use whichever side you wish. If this is 19, then this one will also be 19.6. And then if this horizontal is 15, this one also will be 15 meters per second. You can put the units. So here I think you'll be done, because you just need to say let the resultant velocity be v, and maybe let the angle be theta. So you can now calculate v from the Pythagoras theorem. So v will now equal to the root of 15 squared plus 19.6 squared. This is Pythagoras theorem. Or you can say v squared is equal to 15 squared plus 19.6 squared. And finally, you'll get your v as 24.7. And this will be meters per second. And then after getting the v, you can now get the angle, and this angle you will just use tan theta. Say tan of theta will be opposite. The opposite of theta is 19.6, and the adjacent is 15. And then you will have your theta equaling to tan inverse of 19.6 out of 15, and your theta will finally equal to 52.6. I think I have lacked space. Let me first erase some. So it will be your theta will equal to 52.6 degrees. That is your theta. So finally you can conclude and say the resultant velocity is 24.7 meters per second, and the angle is 52.6 degrees. I think you realize how simple these things are. You can now be able to calculate all the questions concerning horizontal projection. We are going to look at projection at an angle in the next video. Please, you can like the video, or you can subscribe to our channel if you wish, if you like the video. Thank you for watching. We meet in the next lesson.